Welcome back. So you get what RAG is, right? It's how you give a LLM its own custom knowledge base. But the real question, the thing we're going to tackle today, is how do you actually, build one? Okay, let's get into it.
This is really the heart of the matter. It's one thing to know the theory, but what about the practice? What's the map? We're going to break this whole thing down into 3 essential components, basically creating a blueprint you can use for pretty much any RAG system out there.
All right, first things first. Every custom brain needs a place to store all its unique knowledge. This is its long-term memory. It's where you're going to put all your company docs, your research, your personal notes, literally anything you want your AI to know inside and out. In that memory, well, it's a very special kind of library called a vector database. Now, the key thing to get here is that it doesn't just store words, it stores the meaning behind them. It organizes everything based on context and relationships, which is an absolute game changer for how we find information. Just look at this comparison because it makes it so clear. A traditional database, it's super literal. You search for Apple Computer, and that's exactly what you get back. But a vector database, it understands concepts. You can ask about a Cupertino tech giant, and it knows you mean Apple. That's called semantic search, and it's the magic that lets RAG find the right information, not just the word-for-word match. And to make this a little more real for you, a couple of the most popular tools you'll see people using for this job are Pinecone and Chroma. They're built from the ground up to handle these really complex vector searches at incredible speeds. Okay, so we've got our super smart memory system, but how do we get our regular human language documents, like PDFs and text files, into a format that this numbers-based database can actually work with? Well, we're going to need a translator. And that translator is called an embedding model. Its entire job, the only thing it does, is read a piece of text and turn it into a long list of numbers, that's the vector, that perfectly captures its meaning. It's basically turning our language into the universal language of math that the vector database can understand. So let's just trace how this works. It's actually a beautifully simple process. You take your text, you feed it through the embedding model, and boom, out the other side it comes that meaningful numerical vector, all ready to be stored and searched in our AI's long-term memory. So let's recap. We've got the memory and we've got the translator. We just need one last piece to connect everything and make it all work together like a well-oiled machine. We need the central nervous system for our AI brain. This is where a RAG framework comes in. I want you to think of it like the conductor of an orchestra. It doesn't actually play an instrument itself, right? But it's the one telling the embedding model when to translate, the vector database when to search, and the large language model when to speak. It manages the whole flow of information. And the 2 biggest names you're going to hear about for building these connections are LangChain and LlamaIndex. They give you all the tools and the pre-built pipelines to make orchestrating all these different moving parts much, much easier. Okay, so we have our 3 core pieces. Now, let's put it all together and actually watch this brain work. We'll see what happens from the moment a user asks a question to the moment they get back a really smart, context-aware answer. All right, let's walk through the whole workflow. First, you ask a question. The framework immediately sends that question to the embedding model to turn it into a vector. Then, it uses that vector to search the entire vector database for the most relevant pieces of information. Now here's the crucial RAG step. The framework bundles up your original question plus all that useful context it just found and sends the whole package to the LLM. So now, the LLM has exactly what it needs to give a factually grounded, super detailed final answer. It just brilliantly shows how all the pieces work together. So, there it is. That's your blueprint for building an AI's custom brain. It's really just 3 things. You need the long-term memory, that's your vector database. You need the universal language, that comes from your embedding model. And you need the central nervous system to connect it all, which is your framework. These are the fundamental building blocks. And with them, you literally have the power to create a specialized expert on any topic you can imagine. So, the only question left is, now that you have the blueprint, what are you going to teach your AI?